Bonjour, tout le monde, goedemorgen, good morning. My name is John Bell. I'm the Healthy Planet Director from the Research and Innovation Department of the Commission. And this morning we have a very important session at a very important moment. In fact, a very important session on the role of climate science. It's also what is called a co-design session. So what's very important for you to know is that the whole purpose of this is to have an interaction between very distinguished speakers, those of you who are here in the room, those of you who are watching on streaming, and then to use the Slido app, which I think you're familiar with, in the instructions to pose your feedback. What we're going to have is a very pretty straightforward structure to the session this morning. We have four world-class distinguished speakers whose reputations speak for themselves. Helene de Koning, who's Associate Professor in Innovation Studies at the Environmental Science Department at Radboud Universiteit in the Faculty of Science. Colin Jones, Professor in the School of Earth and Environment at the University of Leeds, Head of the Met Office NERC project leading the development of the next generation of UK Earth Systems Modelling. Daniela Jakob, Director of the Climate Service Centre Germany and Visiting Professor at Leuphana University's Faculty of Sustainability, and my colleague Arthur Runge-Metzger, who's Director of Climate Strategy in DG Klima. Now, each of these people, I could spend the entire morning just going through their CVs. You have their CVs. They're outstanding people. And when the history of the century is written, it will be scientists like this who we have seen to have started the next narrative for our civilization. Today is also a very important day. There'll be a publication later on today on an Ipcc special report on the oceans and cryosphere, which is going to tell us a number of things in very clear and stark terms about our planet, about our interaction with our planet, about some of the choices that are ahead, and about the need to connect up fundamental science and answer some fundamental scientific questions so that society and our ecology and the way in which we live on this earth can make decisions about how we're going to organize ourselves in the future and how we're going to change our behavior. I won't go into that detail myself now, but just to say this will be the single most important paper written on the ocean since the first maps were written. So how this will work is there will be a number of questions which are being addressed by our four speakers. And I will very quickly go through what the questions are. Then I will give the floor to each of our four colleagues, and they will have 7 minutes to speak. I have found my most polite colleague will put her hand up when there's a minute to go in your 7 minutes. So we don't have to do anything ruder than that to keep the time. And then we will have, when they've all spoken, we'll have an opportunity for an exchange as to what you think and what the questions coming out of Slido or comments from Slido suggest. The questions we have for Helene de Koning are: which of the four systems transitions do you feel is easiest to realize? Energy, urban infrastructure, land ecosystems, or industry? And which is the hardest of those four? For Colin Jones, how likely do you think it is that the central goal of the Paris Climate Agreement to stay below 2 degrees global warming relative to pre-industrial levels will be realized on a sliding scale of very unlikely to I don't know, but we should probably even have another word in there which is slightly more alarmist. Yes, I'm sure you did. Daniela Jacobs, have you experienced extreme weather events? If not, you should have moved to Brussels a long time ago. If yes, above where? Because we're actually going to start seeing this pattern: Mediterranean, Atlantic, Northern, Central, Western Europe, outermost region, but outside of Europe. And again, would you use climate services to adapt to climate change? So these are some of the questions there. And then Arthur will take us through the situation in terms of climate science and the work that is going on in this area. So without further ado, I think I'd like to hand over straight away to Helene de Koning. Thank you.
Sound?
Maybe it's...
I think sound is working. And slides? So good morning. I will speak a little to the Ipcc special report on limiting warming to 1.5 degrees centigrade. My role in that report was that I was a coordinating lead author of Chapter 4 on strengthening and accelerating the global response to 1.5C. And that, I think, one of the key messages of that 1.5 degrees report was that at 1.5 and at 2 degrees, we have very strong mitigation, obviously, to limit warming to those temperature levels. But in both cases, we also have strong impacts and adaptation. So there's no question anymore about adaptation or mitigation. We have to do them both at the same time. So I think there's one key message which wasn't really spelled out in the summary for policymakers or even in the media, is that there's not an either or anymore. And any activity that we're deciding on, we need to see, is it good for mitigation and is it also good for adaptation in line with 1.5 degrees? So I'll take you through a couple of findings in that report and also explain a little bit of the structure, how they came about. And this is one key figure. It outlines the blue envelope is basically the emission pathways to limit warming and to have a reasonable chance at limiting warming to 1.5 degrees. It basically has 3 key characteristics. One is roughly halving global CO2 emissions by 2030. We have in the report minus 45% to 2010, but since we're a couple of years down the road now and emissions have increased, it's basically halving emissions in 2030 compared to now, globally, not just in Europe. Second conclusion, net zero CO2 emissions in 2050. That means you can still have some positive emissions, but you'd have to compensate them with carbon dioxide removals. And the third characteristic is significant carbon dioxide removals in the second half of the century and possibly even before that. So these kinds of changes in our emissions of CO2 only, there's obviously also very strong emission reductions in non-CO2 greenhouse gases, but there the difference between 1.5 and 2 is actually not that big because we're already doing it to the max for 2 degrees, so 1.5 doesn't matter much. But for CO2, the big difference is the big difference for 1.5 degrees is to get to CO2. Now this is not feasible with just implementing a list of technologies. It requires systemic changes, and that's also what the Slido question was about. And we talk about 4 systems transitions, and we didn't organize them in the sort of classic sectors, transport, buildings, industry, because we wanted to make them adaptation and mitigation related transitions. And that, in our view, in our chapter, worked better with these 4. So first we have the energy transition, everything related to energy supply and demand, electricity, but also heat, of course. We have the land and ecosystem transition, and also you can add to that the ocean transition after the release of the ocean report today. Transitions in the field of industry, which relates to everything related to our materials and consumption of materials, and also how we construct buildings, and the urban and infrastructure transition, urban areas, but also the infrastructure around building everything. All very systemic aspects. Oh, could I get my slides back? So how we looked at things in the report is sort of we use the pathways as sort of input in those system transitions because they describe the CO2 emissions. We looked at the feasibility of individual mitigation and adaptation options across 6 dimensions in these transitions, environmental, but also sociocultural and institutional feasibility, developed a methodology for that. Very importantly, we looked at synergies and trade-offs with other societal goals, the Sustainable Development Goals of options in these system transitions. And basically the conclusion is limiting warming to 1.5 degrees means goes hand in hand with other societal goals. But you have to, in some cases where there's trade-offs, manage those trade-offs as well. And importantly, you need basically a jigsaw puzzle of enabling conditions in order to make that happen. And we identified multi-level governance, very importantly, human capacity to do these things everywhere in the world, behavior change, technological innovation, policy instruments, and finance. So all these together add up to some group of answers around these systems transitions. And I'd just like to leave you with 3 key questions, and the other elements are adding to those questions. How can we make these system transitions happen? How can they become more feasible? Where would you look for answers for that? And also, how can mitigation, adaptation, and societal goals be addressed simultaneously? So I hope this explains the question around system transitions somewhat in my very limited time that I have, and I look forward to the discussion. Thanks.
Okay, yes, thank you, Hélène. We'll come back on stage when everybody's finished presenting. So now to Colin Jones, a new brand of optimism I'm looking forward to.
Yep, sure. You may have to wait for Daniela for it. Okay, so while the slides are coming up, I work in the area of developing global climate and Earth system models. I'm at the UK, and I run the UK Earth system model development project, and I also coordinate a Horizon 2020 project that brings together. No, I don't think it's at all.
Sorry, how's that? Better?
Right.
And the slides will come. So I work in the area of model development, global climate model development in the UK, and I coordinate a Horizon 2020 project at the moment that has 7 of the European Earth system models that are feeding into what we called the 6 couple model into comparison project, which ultimately feeds into the next Ipcc report. So what I'd like to do is just highlight 3 particular areas where I see enormous uncertainty and enormous potential as well for scientific research and progress around understanding the fundamentals of the global climate system and understanding some of the fundamental problems in models' abilities to say something useful and tangible about global climate warming. So the first one I'm going to talk about, I'm going to refer to something called the equilibrium climate sensitivity. And I guess I could have had that as a question if people know what it is. It's a bit of an abstract thing that we've used in the climate science and modeling world for about 30 years now. And it defines the equilibrium global warming for a doubling of CO2 relative to pre-industrial conditions. So essentially, we run our models of the global climate system for the pre-industrial period, and then we double the amount of CO2, and we ask if we run them again, what will be their equilibrium climate temperature change? And this is a very, very strong metric pointing towards how the climate system is sensitive to CO2. And the slide on your left shows you on the vertical axis the year from a lot of different models, these are all different models, the year of crossing 2 degrees warming, global warming relative to pre-industrial, as a function of its 1 over the climate sensitivity. So typically the climate sensitivity, we've always thought, lies between about 2 and 4.5 degrees. The next round of models that we've developed now that feed into Ipcc are pushing that upper boundary a bit higher, actually, more towards 5 degrees. So what you've got here is an estimation of the year of passing 2 degrees or the allowable CO2 amount in the atmosphere, which goes together, as a function of the model's climate sensitivity, 1 over it. So if the model has a climate sensitivity of around 2 degrees, we might expect to cross 2 degree threshold quite late, around 2060. But if the model has a climate sensitivity of 5 degrees, then we might expect to cross the 2 degree threshold 25 years earlier. So this is an enormous uncertainty about when we're likely to cross this threshold, phrased either in CO2 concentration, CO2 emissions, or years. The right gives you the primary driver. There's lots of things that feed into this uncertainty, but the primary driver is the response of clouds to a future warming. So here you're seeing now the equilibrium climate sensitivity as a function of the change in cloud reflectivity. So that's how clouds interact with solar radiation. Now if clouds in their amount or reflectivity reduce as the climate warms, then you get what's called a positive feedback you get an amplification of the warming because you get more sunlight to the surface. And if they decrease, you get the reverse, you get a negative feedback. And these changes are very small. We're talking about 1% change per Kelvin warming. This is the primary driver of uncertainty in our ability to say something about climate sensitivity, and therefore something about when we are likely to cross thresholds. So that's number one. There's a strong need to improve our understanding of modeling the climate system, particularly cloud feedbacks. Number two, with that in mind and with the fact that we know, as is shown on the left, so the far diagram is from the Global Carbon Project, and it's showing emissions of carbon dioxide historically, and emissions are still increasing. They are not flattening out. They are not decreasing. They are still increasing. So this implies to most climate scientists, unfortunately, that the likelihood of realizing Paris, which is staying below 2 degrees global warming relative to pre-industrial, all the way to 2100 is very, very unlikely. So one of the things that's likely to happen is what we would refer to as an overshoot. An overshoot in emissions, which might lead to an overshoot in temperature. So what this slide is showing is, this is sort of the pathway of global emissions we're on. This is the pathway of emissions we need to be on to some target. And so we're following this pathway, and at some point, we decide we need to get down towards a target. And in terms of temperature, to realize that will require, as has been referred to already, negative emissions, which means actively taking CO2 out of the atmosphere. The response to this kind of pathway is this might be our desired temperature trajectory. This is where we're headed. This will be the result of that. There will be some kind of overshoot. And I should stress that models say you will not start reducing temperature in the atmosphere until you actively take CO2 out of the atmosphere. And it will be a slow response. It will not be this quick, unfortunately. This is a schematic that should stay flat, in my opinion, and then start coming down. So temperature response to emissions reduction is very slow in the climate system, so we need to start acting as fast as possible. And we need to understand the reversibility of the system to an overshoot, and in particular, how we can develop and deploy negative emission technologies at the scale needed. So that would be a second recommendation in terms of research. And the third goes along with this. So if there is what we would refer to as an overshoot, things may change, and they may not change back on the timescales we would like them to change back. The best example, I think, is ice sheet loss from Greenland or from Antarctica. If you pass a warming threshold that triggers some melt, even if you bring the temperatures back, the melt will not come back. The melt will take a long time to come back. So what is called reversible, it's called committed change. So things like ice sheets, we may already be committed to changes that we cannot reverse, and that will get worse and worse. And of course, ice sheets feed in primarily to sea level rise. That's not the only thing they feed into, but that's one of the primary ones. Another example is permafrost thaw. So as the permafrost begins to melt, or thaw, I should say, we could be committed to changes again, and there's an amplification factor there. There's a positive feedback. As permafrost thaws, it releases carbon and methane into the atmosphere that are greenhouse gases. Ocean circulation may change, particularly in the North Atlantic. The Atlantic meridional overturning circulation, or the Gulf Stream is the surface manifestation of that, is sensitive to warming, and it's very sensitive to ice melt in the Arctic and ice melt off Greenland, being fresh water going into the ocean. So there may be changes in the Atlantic. Once they are triggered, they will not go back quickly. They will take time to go back. And finally, desertification and habitat loss equally. Once you start to trigger changes in vegetation, the response is a slow timescale. And again, there are feedbacks on the ability of the biosphere to take up carbon and impacts on the climate system. So the third one would be understanding these risks and abrupt changes that are crucial both for adaptation and mitigation. Okay, and my time is up.
So now, just to continue, Daniela, if you'd like to take us through your questions. Daniela Jacobs, thank you.
Good morning, everyone. Thank you very much for having me here. I would like to turn a little bit towards the more local and more extreme scales. So we just heard from Helene how important it is to transition all our systems to a low-carbon world and lifestyle. We heard from Colin already the committed changes, which look like not being reversible anymore. And if you read carefully the Ipcc special report on 1.5, you could identify that extreme events in some areas of the world, under those are areas in Europe, and for some extremes have been changed, and you can just see this from observations. So in the time period from 1960 to 2010, half-degree warming occurred. In this time period, you can significantly show the significant change in extremes, here only for heat waves, droughts, and heavy precipitation in several areas of the world. So even if you do not trust the equilibrium climate sensitivity of Colin's models, you can easily assume with another half-degree change, a change in extreme is very likely. So we have now reached decades in which we have a warming of 0.2 degree. This means we have reached a global warming compared to pre-industrial levels of about 1 degree, even more. So we come close to what Colin showed us, and we cross the 1.5 degree warming sometime between 2035 and 2045, 2050 roughly. So with this, we would have an intensification of extreme events. It could be intensified, they can be intensified, they can be longer lasting, they can be in different areas of the world, in areas where you never had experienced extremes, and that's where the questions were coming from. So if you think about what we just learned from WMO, that the last 5 years were the warmest ever, more than 100-year temperature record. And if you look at 2017 and 2018 in Europe, in large areas of Northern Europe, where we had an extreme event in the way that we had rain in northern parts of Germany, for example, mainly raining from September to March, September 17 to March 2018, so that we couldn't do all the harvesting and agricultural practices we were used to do. And then the next summer we had a drought and a heat wave. We are facing not only changes in very extremes like heavy droughts, but also we are facing extreme variability, year-to-year changes in the weather phenomena. And unfortunately, our infrastructure is not well equipped for this. So I think it's very important to realize, even if you do not trust in what is ahead of us, but to realize that we have a lot of knowledge in the back, which we know from observations. We have to continue this monitoring of what's ongoing. Changes are more rapid, and we have to enhance our scientific skills in analyzing the monitored data and connect them in a systemic way. So we have to get prepared. We have to prepare our infrastructure, our health system, our buildings, our ecosystem services, to those new changes, especially these extreme changes. This means climate services can help to do this. During the last 10 years, climate services have developed. They provide hydrometeorological information, for example, through a network from WMO called GFCS, Global Framework for Climate Services. But there's another network called CSP, Climate Service Partnership, where knowledge sharing is mainly the focus. Knowledge sharing, understanding what's best practices, what has failed in climate services to understand and link the climate knowledge, the climate change data, the local information to our practices. For this, we need much more robust information on how the weather is changing on a local scale, meaning temperature, winds, freezing days, heavy precipitation, in order to understand how we can get better prepared, to connect disaster risk reduction with climate change adaptation, to get the best out of both, to be not so vulnerable for today's changes and those in the future. So I think it's important to understand that extreme events can be everywhere, even in areas where we have not observed them and where we are not prepared yet. And we have to understand how we can predict those project changes with climate change. And for this, I think it's important to connect the knowledge on the ground, the observed understanding, and what we know about the future through all scenarios and climate change projections. Thank you.
Thank you, Daniela. Now, Arthur, following those three presentations, I'm sure you'll be able to draw some strategic lines.
I'll try to. And thank you very much for the three presentations. I think they just show how relevant it is to have science working together with policymakers. Because these three areas you have been presenting are the things kind of we need to take into consideration in the coming years. We are at a stage in Europe where we have a change in the Commission, a change in the Parliament, and what we see is much more public interest in moving forward, trying to tackle climate change and putting a lot of pressure on politicians, which in fact then puts pressure on us in the different government representations, whether it's at the union level or at the level of member states, or particularly also at the level of municipalities and communities. And when I look forward, we are at the present point in time having a huge policy discussion in Europe. Where do we want to move in Europe? How do we want to contribute to the Ipcc report on 1.5? The Commission has made a proposal. We say it's not only carbon neutrality or net zero CO2 in 2050. We think Europe needs to be net zero greenhouse gas emissions by 2050. And looking at all the reports we had from the science, particularly all the people working with Helen all around Europe, I think we are confident that we have the solutions in terms of technologies. We have, at least in the coming 10 years, I would think, we have the ability to do that in terms of the economics in Europe. What is really missing is the political will and to get it done over time. And I think there is a big question relating to policy, because it's not only giving advice on, okay, how do you adapt to extreme weather events, but it's also how do you manage the transition. And the question that was there, my answer to that was, I think in the energy sector it's relatively simple. We see technology prices falling. We see a lot of improvements of technologies happening. So there, in terms of what we said by 2040, we should be out of CO2 completely in Europe. And I think you see many governments acting on that. The coal phase out is a very active discussion in Europe at the present point in time. Where it's going to be more difficult and where we are limping behind is the whole issue on infrastructure, energy efficiency in particular, where we are not meeting our energy savings targets. And there the big question is really going into the granular things. What is it what is preventing this from happening? Because if you talk to somebody, people always say, oh, that's money lying on the floor. Just pick it up and then do energy efficiency first. But it's not happening in Europe at the present point in time. We are still lingering around with 1% change in renovation or 1% renovation rates, and we have been doing so for the past 3 decades. If we want to move forward in the coming decade, this will have to be tripled. And we don't have an answer to that, how this is going to be done. Brings me to industry. Industry has done a lot over the past years, and a lot of what needs to be done is quite looking at the entire industrial processes. And that's where we will need more research in the coming years. A lot of the solutions are being thought of, but they haven't been tested in a big way. Next 5 to 10 years, I think for us is the time when we have to test some of these at scale. So not just talking about green steel, but doing green steel for the first time and making sure that what we invest in is going to stay in the market and will produce in the coming decades. I think this is going to be eminently important. And then comes land use, the whole issue about the removals. I think this is something that has not really been grasped, even by the policymakers. When I talk about removals, the first thing I hear back is offsets. We are not talking any longer about offsets here. We talk really about removals from the atmosphere. So if we want to credit something in the future, it should be the removals from the atmosphere. It should not be offsets. Still, this is something where policymakers will have to grasp with, and where probably we also need some advice from, in terms of practical policy making, from the scientists. And over all of this is lingering the whole question, okay, where is the climate sensitivity really going to lie? Because this is going to change the whole time perspective. While at the moment there is, I think, in politics an issue of, yes, we need to become quicker, I'm not sure whether it is fully understood how fast we might have to be. And that brings us to, I think, the limits of how fast societies will be able to change. Just ask yourself, we are all living in apartments or houses. When have we planned for the next renovation, and how deep is that renovation going to be? And probably we will hear the wrong answer in terms of what is going to be necessary. And the final thing is this whole issue about adaptation, where I see when talking and going to the field, people are struggling with that. What do we really have to plan for? And there my big question is, how granular is the advice today? I think you were making the point at the end, saying we need to have this kind of local advice, what needs to be done. Because we know if you get it wrong, you might have sunk a lot of money, which we could have used for something else. So to get better on that, and not in 10 years' time, but over the next 5 years, I think that is another focus we need to have in the European Commission. We are now drafting the program Horizon Europe with all the missions and so on. So there needs to be real focus on all these missions, on all these partnerships, in saying, let's deliver on 2050 and climate neutrality. And I'm going to give you that minute. I'm over now. Thank you.
Thank you, Arthur, and thank you, colleagues. I don't know if you'd like to join us here now as we start the interactive part of the session. I think what we've heard in the presentations, there are a number of things. We need to invest in the understanding of the fundamental science that will allow people to make decisions and changes, the science of prediction, of observation, of modelling. We need to find a way in which we can actually relate what science will be telling us with greater accuracy and calibration to local decision making and local thinking and local businesses. We need to look at our infrastructure in the widest possible definition of that word, and in fact at the European Commission we're looking at infrastructure and the climate proofing of our infrastructure, and the infrastructure can also mean the economic and financial systems that we assume. We need to see where the opportunities are for climate services to take root, because we want the European Union to be the first place in the world that can turn these transition in systems into an opportunity to build a better society, a better economy, and a healthier planet. We need to look at the ambition to move beyond greenhouse, not just CO2, but to greenhouse gas net neutrality. We need to assess how we can actually demonstrate at scale what is possible as quickly as possible, and critically, and this is, as we know, is the critical part of our whole democratic crisis that we're going through. We need to find new ways in which decision making and in changes involve people on the ground in the decisions and the choices and the directions that will go there. So science and the application of science downstream has a lot to do in terms of working out how can research and innovation actually help in terms of bringing this decision making to ground. There seem to be areas which are clear rather than easy in terms of energy. There are boundary conditions that we don't necessarily understand as to why certain things are happening or not happening, or are being disseminated or not. There are more difficult and urgent areas in terms of even policy framing, like land use and agriculture and the food system. And there are public understandings, which is going to be a major challenge for the scientific and the policy community to understand the urgency and the need and the possibility of doing something. And last but not least, one of the points that Daniela made, which is the need to connect up different areas of science and practice. So climate adaptation in support of climate mitigation, but climate adaptation now needs to work with disaster risk reduction communities and with crisis response, with investors, with risk assurers and so forth. So a lot of ground has been covered. Now, somebody's going to explain to me how we can see which is the most popular of the questions that we should address. We have a number of individual questions which are coming in. I see Miko Strullendorf has been very active. We can maybe start. Are you in the room or are you here? Hello. Would you like Miko to start? We have a micro for Miko. Can this be thrown at somebody? Yeah. Okay. Throw it in a cooperative European way. Thank you.
So sorry for all the others that they were not ready to write questions already, but now go to Slido and do the same as I did. So I just put 3 questions up. And I mainly work from the space sector, so Earth observation. So that's why I'm seeing that for climate science to pick something up, I think getting downscale and local is a very big thing. We have now a lot of opportunities that there's actually 10 meter or quite high resolution compared to anything which is a climate model or climate reanalysis thing, that these things have to get closer to each other. So I'd like to see a round of you answering that, how likely and how much effort you see there is, but also does it help? Because I think getting people to transition and politics to transition is the whole big question now, that do we actually get into fast gear? And there I do see that, like, it's the climate hostile industry, as I say it, who have been actively trying to kind of like prolong the era of a kind of like carbon emission world to continue because it makes money. And can we kick them when they are paying the politics? Whoops.
Okay. So maybe start, Helene.
Maybe I should just relate most to the last question because that's most in my field of expertise, and it's also, potentially the most politically sensitive one. So, okay, I tend to look at these questions from a more political science perspective, and just looking at the climate negotiations internationally, right? Small island states are arguing for very strong temperature targets because it's existential to them. Oil exporting countries are arguing against decarbonization because it's existential to them. The same goes for industries, right? They work in a certain system, and they are basically, the thing they have to do within that system is to act in the way that they have always acted. I'm not into the blame game or anything. I think we need these system transitions because if the system doesn't change, they cannot change. So it's not with hostility or not. It is just a question of how are we designing our systems within Europe and globally. But I think we're talking about Europe here, in a way that the industry is enabled to act towards climate neutrality. At the moment, those systems, despite the carbon price, aren't there, or are not there. They haven't changed quite enough. And I think that's where these enabling conditions come in. You need the finance system to change. And to give incentives in certain directions. And I think we're seeing that happening, right? The financial sector, I was just in New York, it was a big deal there. Banks are starting to act, and it's encouraging, I think. But you also need the governance to change, you need behavior, you need people to ask for it, you need innovation to help. I mean, all these lights have to be green, and then the industry can act. But just, picturing them there like as if they're the enemy or something, I don't think is helpful.
I'll give a quick response there, which will be a personal one because I work in the physical sciences, and my answer would be to your third question, yes. They are causing trouble. They are essentially trying to maintain uncertainty. They are muddying the water about what is, I think, clear messaging from the science community, and something needs to be done about it. Now, whether treating them as hostile is the right way to do it, I don't know. I don't work in the political area, but I view them as being hostile, yes.
I think it's important to connect your questions. I think it's absolutely necessary to have the observations on a very fine scale to understand where the damage will be created from extremes, but also from long-term changes. For this, we need the connection to the downscaling of predictions and reanalysis, where we have to understand if the simulations, the models are doing the right thing for the right reason, and how we can bring this information from the areas of observations into the non-data areas, the data sparse regions. So we have to bring this together to understand how the local characteristics, like cities, like valleys, like small forests, how they modify the effects of local climate change. And this actually then is needed to understand in the political arena what we have to do and how the local industry is affected in their value chain, in their businesses. And this only helps when we want to discuss what could be a new business model for some of those industries and for some of the nations you were mentioning. It is not a question of saying you can't do this anymore. It's a question of enabling with innovation, motivation and big investment programs the development of new industries and to convert businesses which make no sense under climate change from a mitigation and adaptation side into businesses which are low carbon businesses and which help a sustainable world.
Maybe I can come on that last question in terms of how I see that. I think that we have no other choice than to work with and through industry, because it's a major part of the economy. It's a major part of our life. And I think what we are seeing in Europe is a change in the attitude. When we were preparing our long-term strategy, we got a lot of information from industry on how they think they could change. But I think they're then now turning around and saying, this doesn't mean that this is already a business model that is robust, that can go out there. You need to help us as well on the side of policy. And they do that despite the fact that they get very different signals around the world. If you're in the United States today, I think the signal you get as an automaker is very different from what we are saying here or what China is telling the industry. So I think that's something we need to take into consideration. Of course, I see also how much money is still invested by the petrochemical or by the oil industry in new fields in the United States, for instance, every year, billions and billions. And I always think, oh my God, if that could go into a different direction, that would be much more helpful. But that's political reality, and we have to deal with that. But I think the tide is changing in Europe, and the political will is building to change that. And the interesting thing, it is already rippling through to other parts in around Europe. I was in June in Moscow talking to aluminium industry, steel industry, and also Gazprom. You can't get around Gazprom. And there they are saying, okay, if Europe as a marketplace is going to change and we can no longer give you the natural gas as we did in the past because you want to have something that is carbon-free, how can we provide that? So how much hydrogen are you going to need in Europe in order to fuel your industry in the coming years? So it means that they are waking up in terms of delivering the right stuff that we want in Europe. I think we are setting standards globally because we are a huge market and we are a rich market. And that is, I think, a power we need to exploit even more in the coming years.
Could I just make a follow-up? Again, I stress I'm coming from the physical science, not the political science, but I think from the physical science perspective, these transitions are happening way too slow, just way too slow. And I saw a question that was up there, something to do about, is it compatible to have concentration on GDP and to meet climate targets? And the answer is it is not. You have to change the model. We cannot expect economic growth and address the climate question fast enough, in my opinion.
I would differ on that one.
I guess we may be giving out donuts at the end of the lecture to look at different possible models of economic growth. This is one of the themes that has come up in a number of discussions. I think one of the things that's coming out from people's questions is the issue of prediction. Is the scientific observation, modelling and prediction will move from the scientific niche to the public policy norm. And I think there's been a question that has been coming up. It's moving up and down. There's two questions here, I think, that are leading. One, which is a very pointed question. Do we need to think about the limits of climate adaptation? And after that, I think the oceans are asking to be heard. So maybe, Daniela, to start on the limits of climate adaptation, maybe to explain what that actually means to people.
The concept of limits to adaptation the concept of limits to adaptation, or the wording is used in different ways. Partly it is used in a way that regions, communities, cities are limited in their adaptation efforts. That means there are structural, financial, technological limits so that they cannot adapt to what is needed. The other meaning of limits to adaptation is there a limit which we cannot adapt to anymore? So is the climate change so strong that we cannot adapt anymore? And of course, Helene is the expert on this, not me, but I think this is, the discussion is important on both sides. I think we miss a bit scientific knowledge on how the development of technology and adaptive capacity is changing the limits of adaptation. So from the systems approach. On the other side, Colin would probably say if the Earth is warming by 8 or 10 degrees, then some limits are overrun where a certain way of adaptation of ecosystem, humankind, is not possible anymore. So I think this is still a debate which needs to be, I think in the next years, be a bit more upfront. But currently I think the important is that the climate modeling, the knowledge about the Earth system, the knowledge about the interaction with this human system has advanced a lot. So the ocean, and I would pass this to Colin now, the ocean, of course, is included in the climate scenarios to a certain amount. And maybe you can explain a little bit where the caveats are here for this question about the ocean.
I can. Do you want to say something about the adaptation, as you were referred to as the expert?
I'm absolutely not an expert on climate change adaptation.
Gives me time
I'm
to think.
more of a mitigation person. But I think the answer to the question, do we need to think about limits of adaptation, I think is definitely yes. I'm from the Netherlands. The ocean report that will come out, the special report on oceans and the cryosphere that will come out today, will have very strong messages which I think really affect existentially again my country, and with that the European Union. So I think the sea level rises will see the adaptation response might be migration. And I know there's a scientific debate, on whether migration can be counted as adaptation, but that's definitely exceeding some limits. And it is, as you say, a function of resilience. Sea level rise in the Netherlands has a different impact than in Bangladesh, where capabilities and technology and ability to invest in adaptation are much lower.
So I'm not entirely sure what the question is related to the ocean. What I will say is that so in the models we use for making climate projections, so there is a subtle distinction between a prediction and a projection, and I'm not sure if everyone understands that. So a prediction uses a known state of the system based on observations, and then runs a model forwards in time. So a weather prediction is an example of that. You can also make a climate prediction, but you need to know what the ocean looks like today to be able to make a prediction. So the projections we make, we run our models over the pre-industrial period, then through the historical, and then into the future with different scenarios of greenhouse gases, and we compare model simulated future with model simulated past, and we get a projection. That's for change. That's not a prediction. It's a projection. There's a subtle difference there. But in both of the models that are used for predictions and projections, the ocean is fully there. It's fully included. Dynamical ocean, and in the Earth system models also now biogeochemistry in the ocean. So we include a representation of carbon uptake in the ocean. And we have some representation of the response of the ocean biogeochemistry to climate change. The understanding is still fairly limited, but the structures are there. What I would say in the context of what was just said about sea level rise, one of the big uncertainties that we do not yet cover correctly is the potential contribution of ice sheet melt to sea level rise, and in particular risks around Antarctic ice sheet melt. And that's an area that we simply do not have presently in the models we use. and we need to get somewhere to be able to both understand the risk and model the risk there.
Can I say something to the growth issue, because it was brought up earlier? I think that's really key also for research projects going forward. But it's not just the thinkers thinking up new models of growth. It is also changing the mindset of politics, essentially. And with that, there's a big role, I think, for media. I think if you look at the the Economist of last week, right, it was completely devoted to climate change, front page, etc. However, if you look at the indicators they're consistently reporting, it's basically GDP. They don't report every week on how things are going for various countries around the world in other parameters. So the question is, indeed, what are those parameters that should be reported? Because if media like that, influential media like that, global media like that, are starting to report on something else than just GDP, maybe then the political mindset can change a little bit as well.
Maybe on this one, I think it is a discussion I think we are having in economic circles already for many, many decades. And I don't think that the task is to resolve that debate. I think that will continue. So I don't think that we should start with, okay, let's find a new definition for growth. I think what's more important is, what do you put into these indicators like GDP? And one thing that has come up more strongly is the whole issue about stranded asset. And it fits so nicely to climate change, because you think you are sitting on a beach and you see how your asset is just moving away, or your home country is turning into the Dutch Ocean instead of having the Netherlands any longer. So that is something that will have to come into the calculations, but you can do that within the context of the current growth models. But it's something that is not being done seriously enough, and it also needs to trickle through to the decision makers, who are the ones who are using the asset streams. So the whole question about sustainable finance becomes very important. I think that is where the focus is. If you look at what needs to be done, Helen was quite clear, you need to invest in all areas and change the type of infrastructure we have. So what we have ahead of us is a huge investment agenda. So a lot more needs to be invested than what we had planned anyway, and we just need to invest it into the right things. So we need to climate-proof those investments. And that, I think, can change a lot. But we need to take more money into our hands in the coming years.
Good. I'd like to, we've only got 5 minutes left. I'd like to give the floor to the floor. Sheila Hammonds was the person who asked the ocean question. Could we throw the micro over to her, please? Glad you're not a fisherwoman.
Thank you. That's much better. Yes, sorry. So my question on the ocean was really not about whether we have models that have the ocean in it, but whether we have the data to put in the models and to deal with the uncertainty. And that's because we have a lot of data on land, and we have quite a lot of data on the ocean in the northern hemisphere, but actually in the southern hemisphere, which is where most of the ocean is, we don't have so much data. And really, how does that affect the uncertainties of your predictions? And then also adaptation, because the ocean is going to have a huge impact on how much adaptation we need.
Yeah. Okay. I'm going to pass the micro around the room a little bit, and then we can allow our speakers to pick up on these comments. You know, there's a huge concentration on the ocean horizon in Europe, but we need to bring the ocean and the scientific community and the ocean together to provide the basis for that. We need to turn the lights on in the ocean.
Related but separate question. My name is Monica Rieber-Farm with the Global Water Partnership. I see most of adaptation translate through water, whether it then ends up in public health or whether it ends up in desertification or wherever. But I also see more innovation there happening in the countries that are most hit. So I'm wondering how through Horizon Europe we're going to make the connection between European research and research in the countries that experience it most, so that we don't get a disadvantage on the research end, on our end for this.
I can maybe answer that very quickly. There's a specific initiative called PRIMA. We're going to be looking at the systems changes that are needed and developing platforms to work with international partners to connect up solutions along the systemic lines that we're talking about. There's probably English for that I could give you in more sentences. What I would suggest is there will be sessions on this, and please go to the sessions.
It was not a technical question how to apply for this. It's more of a political economy question because we do not see much innovation in the water space at all as far as water management is concerned. And that seems to have to do with a lot of the fact that it's owned by governments. It's very sluggish in making changes happen. So that goes to the system question on how can we speed this up when the pressure may be a little longer away.
And one of the answers that research, innovation, and science can give, which is the space that we're in here, is to convene people around what the alternative solutions are, to have demonstration sites. For example, with Prima in the Mediterranean, north and south, you were doing water in agriculture. So we can show to the regulators, to the owners, to the operators what is possible, and to use that to shift opinion. I would just, we've only got 5 minutes, so I will be quiet now and just move around, and then we'll give the panel the last word.
Hervé Bersagon, I'm a physicist. I would like to take back the debate on the carbon dioxide removal and negative emission technologies, because we saw from the first two presentations that they are really essential if we want to manage the climate problem. And I think we are not at all investing enough, and especially there is no concerted plan, there is no driver from the Commission. So how can we organize and how can we give really incentive, very efficient incentives to research and industry?
Thank you. I'll take two last questions.
I just would like to come back to the modelization with the impact of the oceans. I think you've been presenting the permafrost and the link of the permafrost, but being in Monaco recently, I've seen that there is a big forget about the gas methanes in the oceans, and increasing to 1 or 2 degrees, that could have a very big impact and completely change the scenarios. And I think we have to take that into account, especially that for the moment, the oceans are taken as part of getting the methanes not released to the atmosphere. But recent studies, especially in the Black Sea, we just came out of the Black Sea, show that there is more and more gas hydrate released in the oceans. And I think this will really have an impact on your curve, because the methanes is 20 times stronger than the CO2 as a greenhouse gas effect.
Can I give the last word then to respond to those questions and comments on water, on ocean data, on negative emissions, and indeed on basic science and some of the issues, and the other questions that have been raised. So I give it over to the panel.
I can do it quickly on. So I can take quickly the two oceans. So in the context of the Southern Ocean and improving our understanding and observations, I 100% agree with you. We need a much better understanding, and that's observations, it's theory, it's a whole lot, both for the dynamical and the biogeochemical activity in the Southern Ocean. 100% agree. On methane emissions, so we've done some work on that in our area. So in the UK, the research on that, well, we've looked primarily in the Arctic. The feeling is that probably most of the potential of most of the methane clathrates that will be thawed at that, in the Arctic at least, that the methane will be absorbed in the ocean actually before it gets out into the atmosphere. But other areas, you're right, like the Black Sea and places like that, I would classify that as what I've maybe listed there as there's many unknowns. And that's an unknown. We actually just don't know. But you're right, it's a risk. It may be a risk that isn't realized till warming gets very large, but it's a risk, and it's a risk that we largely do not know about. So I agree with you that we need to, there's basic research to understand these issues, yeah. Because they are big risks, you're right, yeah.
Maybe I can talk to the water issue. I think it's very important to understand and connect to the national adaptation plans. So climate services are also developing guidances and trying to understand in which level of governance the most effective interference in order to enhance adaptation and mitigation on a local or regional scale needs to be inserted. And I think this is a way where best practices, but also new technology and innovative ideas could be mainstreamed in the different level of governance. So it's a typical climate services question which goes far beyond the delivery of hydrometeorological data, but the implementation and use of this is part of climate services. And I think what is really important when we also talk about the methane and all the uncertainties is to understand that we cannot do the one or the other. We have to do everything at once. We have to go through all levels, the local to the international level, the private, the industry, the public. We have to do everything at once, and this is, of course, very challenging, can be frightening, but can be a huge opportunity for many of us. And I think here, Europe needs to be in the driver's seat.
It's hard to add to that, but I think the questions are very... I haven't
negative emissions. Okay, I'll leave it with you.
Thanks for reminding. I think many of these issues are systemic. The negative emissions one, the water one. I'm involved in a Horizon 2020 project called Sim4Nexus, trying to deal with the water, food, land, energy, etc. Climate nexus. Conclusions are: it's possible, hard, but possible to model it. The implementation, where does it land in policy? So not just the technological innovation, but the institutional innovation and the social innovation associated with it. That's where the difficulty starts arising. There's just very few incentives for policymakers to look at things in a systemic way, and that needs to change. On the negative emissions, I think it's really it's, as you say, more urgent than we think. It is. We tend to think, 2050 net negative needs to be realized at some scale globally. That means, from an innovation perspective, that we should have started this yesterday. And I'd also like to emphasize that negative emissions is not just bioenergy and CCS or the more technological solutions. There is already experimentation in, for instance, biochar, soil carbon sequestration, which increases the soil carbon content. We tend to look at the atmosphere, but the soils are extremely important. And there's a lot more co-benefits associated with those kind of options. However, they need societal embedding. Agricultural practices would need to change. So we again need this institutional and social innovation along with it to make it happen at scale. But a very important question, and I think we better start on this sooner rather than later.
Okay. My response to that is that it has started, because our forests are sucking up a lot of emissions in Europe. So we have negative emissions already today. The question is, how can we maintain that? And that's probably also a research question. When I was traveling during this summer in several parts of Central Europe, you could see forests dying. So the question is, what we think is still a promising avenue in the year 2050, is it really a promising avenue? I think there's a fundamental research question. Often we model our mitigation without taking into account the climate change that is going to happen on the way. So I think that is a very important question. The second one is then, of course, we need to get bigger than the 100 million tons we have accounted for at the present point in time. That will require new incentive systems, and also looking at the other more technological parts of carbon capture and storage, whether it is BECCS or whatever, but also looking at how we can fix carbon dioxide in materials. So there's one research question in terms of how do you do that? Can we be better about it? Capturing CO2, putting it forever into materials, which I believe is a big research question in the coming 5 years. And then the incentive systems, and we will start working on that relatively soon in terms of what does it mean in terms of accounting, who is the one who we need to incentivize. At the moment, we do the accounting on the existing negative emissions, or I prefer to call them carbon removals, at the level of member states, but I think we need to go probably one level further down to the farmers and foresters.
Could I just say one word on your comment as well, and stress that global negative emissions means globally we're taking out more CO2 from the atmosphere than we're putting into the atmosphere.
Yeah.
That globally, not Europe, globally, more out than in. That is a massive challenge. Massive, massive challenge. Yeah, I agree.
Okay, thank you very much. We will have a summary of this written up. It's very important for this meeting and all the other meetings. You make your views heard on Slido. These will be part of the strategic planning process of Horizon Europe and setting direction. To conclude, if I can, the European Union is not a superpower, but we have superpowers collectively, and one of them is science, and the other is participation and diversity, market signals and regulation. So what we need to do with our instruments now, as this is the new mission for the European Union, to be the first climate neutral continent on the planet and an enabler of those who want to get there, is to hear from you in the course of today and tomorrow. How should we do this? What pathways? What areas? Please feedback. And now I'd like to give you some short feedback to our speakers, our outstanding panel. Thank you very much.